Okay, so in our view, Windows Virtual Desktop brings a lot of, and don't have to tell this group, but it brings a lot of power to end users and being able to extend into both the Azure environment, but also work with the existing IT footprint. And to get there, VDS's main objective falls into three buckets. The first is on the deployment side. And we're not talking about a straightforward go to the Azure portal, create a host pool from there. We're looking at probably what we would call the enterprise class types of deployments, where we're trying to deploy into either maybe a number of regions, or we're trying to scale to a large number. We might have a restrictive Active Directory or network environment to deploy into. So I think our strength sort of lies towards that end of the scale. If you're looking at an architecture that needs to fit Windows Virtual Desktop into that, we'd still handle the small, straightforward ones as well, but we do tend to see a lot more activity on the sort of the enterprise side for those pieces. And it's a pretty straightforward process. You fill out 2 pages. There's a little bit of pre-architecture in terms of determining, how your Active Directory reacts to it, what you want to choose in terms of having VDS deploy your network components, or if you already have a existing Azure network scheme or restricted access to that, you can tag the subnets that you want the session servers to go on, and then where you want our control server for. But then from that perspective, once we fill out those 2 pages and choose a couple of elements, that Active Directory, the network, and then our storage choice, which for us is typically Azure NetApp files, it goes through and uses Azure Automation. It takes about 50 to 55 minutes to deploy the first site or first Azure region that we want to deploy. And from there, we can just start building out host pools and adding users and app groups from that. So it's relatively straightforward to deploy. And then once we're in deployment, that's where the focus of the application changes to managing all the components of the virtual desktop environment. And I'll show you a little bit here in terms of both supporting end users, changing and modifying things, adding components very quickly, adding things from an automated point of view. We have a full REST API that sits behind our web app that we'll look here in a minute. So if we want to do this from an orchestration layer, maybe we have a bigger product that does governance or change control, and then we want to drive that into a set of calls to the API. We can do that in lieu of having the administrator do it from the UI console. But then the other half of that is, how do we take care of everyday tasks? So supporting users, getting feedback on which sessions might be in trouble, checking on the environment in terms of sizing, elements like that, getting feedback from our Cloud Insights product to tell us about those pieces. Are built into the product, and then from the day-to-day task type thing, we can manage the creation and versioning of images right within the product, so you don't have to go back out to the Azure portals to do that. We allow the administrators to access those and do their own application administration, adding applications, changing configurations, setting registry entries, all that type of stuff can be done right in the image that we're building. And then once we're done, we have VDS turn it back into an image by doing all the sysprep steps. And then day-to-day stuff like resizing the FS Logix containers back down to a reasonable size because they tend to grow a lot. Our scripted events environment allows us to add our own automation tests to what VDS does in its sphere of control. We can add tests to that using either PowerShell or Chocolatey or one of those. So focus on allowing administrators to take their Windows skill set, their Windows scripts, and transfer those into the Windows Virtual Desktop environment. And then, like most products, there's an optimization element here. So everybody focuses on, how do I turn the virtual machines on and off at the right times? We have elements for that. We do both workload scheduling and live scaling, as we'll talk about here in a minute. But we think it goes beyond that a little bit. Just turning VMs on and off will save you some money. But in work we've done in a joint study with the Microsoft team, we also need to size the storage correctly. Not so much for the capacity, because everybody sort of knows that grows over time, but the throughput and being able to change that as we have congested times of the day. In the morning when we're pulling user profiles up and getting sessions going, and then more importantly, the writes at night tend to be a little bit more aggressive, and we might want it to increase our throughput temporarily. And the way we do that with Azure NetApp files is to increase the size of the volume temporarily to get higher throughput, and then we can resize it back down once that busy period's over. So that kind of optimization goes beyond just the virtual machines. And then we acquired a company called Spot a couple of months ago, and their focus is even more aggressive beyond just optimization in terms of machines on and off. They also have a algorithm that looks at historical data and looks at the utilization pattern for a particular customer and recommends not only when they should be on and off, but how should I purchase those? Should I, how do I mix 3-year reserved instances 1-year reserved instances, and then spot purchases and preemptible spot purchases in addition to the traditional pay-go type model. So we're working on that particular element to say, okay, if you want, you can be as aggressive as you want in optimizing cost beyond that. So there's an element there on the resource side. There's also a timing element. We want the administrators to focus on unique tasks and things like that, as opposed to having to go and drive or write their own scripts, create their own context to do some of the day-to-day tasks, so we can focus on supporting users for that. So that's sort of the overall objective for the product. Structurally, pretty straightforward approach here with a couple of unique things over some of the pieces here. The top part is a web application REST API SQL Server as a service in Azure combination that runs in multiple regions. We use Azure Traffic Manager to give us both local, the closest access to the web app instance as well as the API instances, but also to give us failover if we need to. Big believers in using the Microsoft native components where we can in our own solution, because if we're going to recommend it to customers to have their own HA and disaster recovery capability, we want to make sure we're using that ourselves for that piece. So that web application talks to each what we call a deployment. Think of that as a localized customer deployment into Azure, and that's the right-hand box here. We put a control machine called CW Manager into that environment, and it runs a couple web services, Windows services, one to talk to Azure, the other one to talk to the local Active Directory and the local VMs within the Windows context. So by having that split control plane, we can interact with the Azure components when we need to, using a service principal security context, and we can work with the Windows local Active Directory environment. Again, in a limited security environment, we use a service account that's within a security group, and that allows us to have just the permissions we need to do automation within the Windows Active Directory environment without having to ask for more than that. So that's a little bit different than just giving, hey, here's my domain admin credentials and putting that in storage. We feel that there should be an automation account for both sides. And then once we have those in place, we can do all the automation we want because we've asked for the right permissions to go out and build out the rest of the environment for that piece. So the gray box on the right-hand side is put into each customer deployment. And then obviously Microsoft controls the green box here as well as the client on this side. So we're an overlay to WVD, but we call directly from either our global control plane up here in the web app and the UI, or from the local CW Manager machine. We make all of our calls using the using the API level. We don't really deal with the PowerShell script level all that much because we prefer the performance and the security of the other one. That's it structurally. Just a couple of examples. I went through all these tasks here. We'll go through a couple of these in the UI. But again, trying to help people with not only just managing the WVD environment, but all the other pieces. So the application tier is where we're spending a lot of our development time, working not only with the newer technologies, when we talk about MSIX, app attach, and stuff like that, but also being able to deploy repeatedly into the environment and choosing the right the sort of deployment mode, right? So some things, as app attach comes online, will be very useful to put those again on a high performance storage layer like ANF. Makes sense. Whereas other applications are just not that friendly to that approach. So you want to do something with scripted events on our side. So maybe you're going to use Chocolatey or Winget or something like that to do the deploys to each of the session servers. But in conjunction with that, we also deploy the elements for things like the FS Logics configuration. Again, tasks that you want to be done consistently and automatically. We do have the capability to vary that by location. So that's a little bit different in the sense that we see the world as sort of one deployment, but as many what we call VDS sites as we need to support people in different regions, because we feel that there's while Azure has a lot of strength, there are some limitations in terms of deployment. How many components can we put in? How many API calls can we make out of the same subscription? The way VDS is designed is we can scale that either by location or just by number of users. We can put, if we have 8,000 users, we can break that up into 2 or 3 different pods of users so that we're not running into some of those limitations. And I did mention the automation is one of our areas of focus. We do fit into not only the Microsoft world, so we have the security context, and we can what we call create context around some of the calls, so that you don't have to dig through and figure out which service principal should be aligned, which ARM call to make for particular components. But it gives us the capability to talk to other environments, whether they're on-prem, Active Directory based, as I said, orchestration based, like a ServiceNow or something like that. Gives us the capability to talk to the rest of the world and not have to run everything uniquely in the Microsoft context for that, because sometimes you want to just abstract that up to a higher layer so you don't have to make as many calls or know as much of the underlying plumbing for that piece. And then within the Windows environment, that scripted events component I talked about allows us to use a identity in the Windows domain and run the scripts in a local system context typically, but allows us to target either machines or the storage layer or both with some of those events. So we do want to make sure that everything we do from a interactive user admin type side, we can also do from an automation side as well. One other comment to make, and then we'll jump in, show you a little bit of the product. Behind all of this, as I mentioned, the WVD part obviously focuses on compute. We do have a number of services that what we call fill out the rest of the virtual desktop. So I think a lot of you are familiar with Azure NetApp files and how we interact with that, how we we automatically deploy that and do the configuration so the administrator doesn't have to. But beyond that, we use the Cloud Insights product for the feedback loop so the administrator can see what's going on. Especially in Europe, we have the capability to add cloud compliance to the environment. So our cloud compliance product will go look for GDPR type sensitive data. Even if it's stored in the FS Logic containers, we can actually review those. And it uses its own level of artificial intelligence to figure out which pieces of data may be out of compliance with the data protection policy and identify those. So that's a product that gets deployed side by side with VDS in the NetApp family. But we do have a test environment and a demo environment to show you how they sort of interact with those two pieces. We do have customers that tend to work across locations, and the biggest use case for global file cache is to provide local access to that beyond just user profiles, but also large files. We tend to see technology companies / engineering companies with very large files that they need to share. And they need to be, you could download them from OneDrive, but it would take a while every time you need to use it. So we're looking more at the ability to have those files shared across Azure regions. And then when you're local to that file, you pull it down into your environment and you don't pay the time penalty for putting those pieces up. And then the question we typically get is, okay, I have my virtual desktop environment all running, WVD is all set, it's functioning correctly. How do I back up my data? Because you don't typically need to back up all the machines, as we know, but we do want to have a reliable backup and retention. And instead of adding a third-party service or even relying on Azure backup, we do have the cloud backup service that is tied to the Azure NetApp file storage layer. So that is an option for us. It does do a backup with all the ONTAP technology that NetApp brings to the table in terms of dedupe and compression. It will back that up to Azure Blob so that your on network and recovery is right there, and does use an integrated service to the NetApp storage layer. So you don't have to mix and match products to get there. SaaS backup does the same thing for Microsoft 365 files. So we do have customers that combine that piece to cover off the rest of the information, whether it's OneDrive, Exchange, Teams messaging, and SharePoint sites. All those can be backed up as well in the environment. And I did mention that Spot is relatively new, but we'll be using that to optimize all the cloud resources, especially the ones that we use for WVD. Okay, I'll take just a brief pause there to see if there's any questions. Otherwise, we'll jump into the application. Okay, so this is Virtual Desktop Service. And as I mentioned, we break down the deployment into two elements. First is the deployment concept, and I'll drill down here just to talk about a couple of the elements for this piece. So the deployment allows us to take the instance and all the security around that instance, including that service principal, and focus on that context for this administrator. As you can see, it has a lot of the information that we can support both RDP, RDS sessions as well as WVD sessions, but gives us which Azure tenant am I tied to, a lot of the feedback information for that. The one thing I would point out is that we took that concept and said, okay, that's great if I have one group of users in one Azure region. But how do I do this if I want to support multiple regions? Because a lot of things are going to be different. Maybe the resource group is different. Definitely the network's probably going to be different VNet, different subnet. And I could even break down the components into other things like my Azure NetApp files. I could have a different Azure NetApp file set up for Singapore than if I had one in Munich, right? So I need to be able to support both of those. The other advantage is if I want to go across Azure subscriptions here, I can actually do that with a VDS site, so that I'm, as an administrator, I'm still running the same instance of VDS, still talking to this, about and managing the same group of users and applications and data. And after about a 10-minute setup process for the VDS site, I don't have to worry about physically where all of the users' components are listed, their virtual machines, the storage layer, the networking. Once I've made that association between all of these particular components, I can focus on just the host pools and things like that. The other thing I would point out is that we do have the capability with a VDS site to separate out the networking and the VMs into different resource groups if that's the choice of the customer. Because some folks like to do it by role, some like to do it by location, some like to do it by role and location. So we do have the capability to, for each site, specify what we want the automation to pick up when we're creating a new virtual machine, for instance. We can tell it that it's going to be in this region with this subnet, and even this different resource group if we choose to, and that allows us to span the locations. The other place where this comes into handy is that we've run into a situation where we can usually get probably 3,000 or so machines in before the the API calls we need to make start running into the subscription level API limits. By doing 2 sites in the same Azure region, we double the number of subscription-based API calls that we can make, and that allows us to scale horizontally as well. So we do have this capability to create this architecture where we do groups of users either in different locations or in the same location, just multiples in the same place, so that we get to span those different places. Now, obviously, when you change subscription IDs, you want to make sure that you have permissions and all that kind of stuff set up for that. But that's just a bit of a detail as we go through into the site setup for that. But we can do different sites. One thing I'll also point out is that, oops. As I mentioned, we do have the ability to come in here and add our own images. So we can basically pick up the servers that we want and go through and do a deployment. Now, this works for both the RDS side as well as the WVD side, but we effectively take an image out of the Azure Marketplace and then go through and build out the information that we want. And then once we've built the machine, we can log onto that machine and deploy applications. Once the applications are done, then we tell VDS to go ahead and seal that back up and turn it back into an image. So as we go through here in a second and do our own host pools, we can actually take our own customized images without ever leaving VDS and use those as the basis for deploying the WVD host pools. Okay, so we will go over and look at our workspace. And there's not that that many differences with our approach to this. The only thing I would say is that the workspace concept in WVD is tied to our site concept, so you can tie the two together. So you can create the policy grouping with workspaces and tie that to a VDS site for those pieces. I'll just do a couple of example tests here and show you how it works. So host pool, we can do. There we go. And then we just basically make a set of selections here. So we go through and we can choose where we want to place this pool. We can check which workspace we want to associate that pool with. And since we've made the site selection, we don't have to do any other further selection in terms of network or resource group and all that kind of stuff. It's already handled for us. And then we make the basic same choices that we're all familiar with when it comes to deploying a WVD host pool. We can pick ephemeral versus persistent. We can also choose one of our templates here, so I can either take the ones out of the Azure pool, or I can actually do one of my own custom templates. It looks at the subscription itself to determine what images are available for that. So if I put my new images in that subscription, it will see it. I can also use Azure Shared Image Gallery, and if the permissions are set for that subscription to see those as well, we can choose one of those. So we do have access to all those pieces. Machine size is basically driven by the location that we've chosen to put it into, and then we just tell it how many more of these we want to build out. So I think we benchmark pretty much every week about 100 machines, and we're right about 36, 37 minutes to do 100 machines. We can do 420 simultaneously into the same site before we start hitting API limits for that process, and those take just about 2 hours and 45 minutes, somewhere in that range for those. So the way VDS does that is it breaks it out into separate sets of threads. The threads make the appropriate API calls to build the machine, put it in the host pool, add it to the Active Directory domain, and then do any customization like adding the FS logics, as well as we'll see here in a second. The scripted events that we run allows us to add steps to that VM creation process if we choose to do that. Any questions on the general setup for those pieces? Okay.
You can also ask them in German, and Patrick can translate it if that's an issue. So it's no problem.
Absolutely. Just ask your question or just paste it into the chat. That's not a problem.
Yep. And then Patrick can interrupt me and say, "Hey, we got a couple of questions. I'll just watch for the number to go up." That'd be helpful. So in terms of scaling, I mentioned at the top there the two pieces that we approach: the live scaling, and you've probably seen some of the preview stuff at Ignite. We're very similar to that approach that they're working on to integrate to the service. We'll switch over to that, I think, at that point. But for the meantime, our live scaling uses those services to evaluate the stream of login and logouts to identify which session servers need to be turned on for that piece of it. And we use a couple of simple rules for that. The first is if we want to take the pooled approach and power on servers, we're going to tell it the maximum number of users on a server. That sets the max for the pool. And then we'll tell it when we want the next server to come on for using depth first, so that we turn the next server on in time for the next set of users if we fill up this particular server that we're targeting. So we can tell it to set its own ratio, but we can also tell it, for a busy part of the day, I want to add an extra couple of machines so that I'm always ahead of that request pool. So if you remember the Ignite video that they did, we had pools, up and down peak times. You might want to have more machines on, say 6 in the morning to 10 in the morning, but you can also tell it I want a different schedule for sort of steady state during the day for those pieces. So live scaling will allow users to stay on, and it doesn't force any users off at the end of the day, but it constantly evaluates to see if if a server goes empty, the next session that user logged off and the server is now empty, it will turn that server off in its next cycle, which is typically the default is every 15 minutes. It will look to see if, okay, I've identified the server is empty, let me turn the machines off for that piece of it. So you do have the ability to scale up and down that way for those pieces. The other element is a workload schedule for each one of the host pools. So I can tell it for each pool what I want the schedule to be. This is for, again, much more useful for the targeted pool or the dedicated single user pools where you're assigning machines at random. Both of those can be targeted for the scheduling component. Individual ones where I have a dedicated machine, those are typically driven by what we call our wake on demand, very similar to the start the machine on session start that WVD does. We can actually wake those machines up in time for the user to come on. So combining all three, wake on demand, live scaling, and workload schedule allows us to make sure the machines are on when we need them, but aren't on any other time, especially at night when we're not using those pieces for that. So the scaling and optimization side is pretty much up to the administrator to set the rules, and then we typically use Cloud Insights to give us feedback on, hey, are we turning the machines on too early? Are we running machines at a lower capacity than we want? We can use that as the feedback loop to finish those rule setting type activities. And as I mentioned, our future right now is to look at Spot and other optimization side from the NetApp side to augment what the native WVD stuff will do. Okay, did want to mention scripted events. Sorry about that. So scripted events allows us to combine a couple of things. One is the sort of that context where we have the services running local in the environment. The second is that a lot of administrators like to use their preferred language, whether it's PowerShell or Chocolate or something like that, to do things in the environment, but they lack the context with the Windows Virtual Desktop unless they sort of put it in place themselves. So we'll just take one example here. This script is from Jim Moyle on the Microsoft side for compressing the FSLogix profile containers. And it's up there on GitHub, so you can go up and get it yourself to run that piece. But what we did here is said, okay, well, we know that we want to run this on a regular basis, but we gave it the context of where and when do I run this script. So we uploaded the script to the library, and then I come down here and set an activity to tell it when to run that. And I have a couple of choices here. So you can see I've set this one up to be recurring every Saturday morning at 1 a.m. I'm going to go out and have it resize the FSLogix containers and bring them back down to size. Now I can change that when I go in here. It might not be appropriate for every type of script that we want to run. So I can choose, instead of scheduled, I can choose a trigger event, like every time I create a server. This will be one of the second to last step before we turn the server over to the administrator. We can write our own scripts to run at the end here. And we'll execute those at the end of that process. We can also do creation for create user and delete user. So again, we can move files around, customize environments, assign application entitlements, whatever we want to do. If we have a create user sort of workflow and governance process, we can implement that using scripted events here for that piece of it. We can also do things from a triggered event where we have a manual trigger point. So either I run it as an administrator or my API call can manually trigger the script as part of a process. Or if I'm updating applications, I can choose to either do it on a trigger that I've defined, or I can tell it every time this application install is requested or uninstall is requested, I can run whatever script I need to do that. Now that might be as simple as just having execute, PowerShell having the MSI run, or using a more complex approach like a playbook, Puppet Chef type approach. And as we see the app attached stuff goes to private preview, we can also decide to trigger that that both creation of putting that in the storage layer, but then associating that with our host pool, we can do those steps from here as well. So this is sort of an environment where we stop our automation, our steps sort of come to an end, but the administrator can pick up their own steps and apply that to the Windows environment however they want to choose. Now, I do have customers and partners who do combine both. So they take our API and they will make a trigger event from here, call either our API or the Azure API, or even something like the NetApp Azure NetApp Files API from here and get the feedback loop during this event. So this is a framework and a programming environment that allows administrators to really customize the environment from where they want to start. So that allows us to have a lot of flexibility, and then also allows us to adjust to changes as they come along. Things like the RDP short path type stuff that just came out. That's basically a set of registry entries and a little bit of reconfiguration. Even though that's not part of our automation yet, we can do our scripting from here to drive that change if we choose to on the configuration. So there's a lot of flexibility for customization, but there's also the ability to evolve with the times as we go along. Okay, one other element to show, and then we can take a couple of questions, I think, before we get to the top of the hour here. So I mentioned Cloud Insights. Cloud Insights is an overall data collection and monitoring and feedback and alerting loop that we use across all the NetApp products, as well as any other cloud or on-prem based product. It's got a long tradition of being able to collect information from pretty much any data source, and once it's there, turn it into useful things like dashboards and alerts. So I'll show you a couple of here. This is by no means a comprehensive listing of what it can do, but I did want to talk about a couple of elements. So the first thing to know is that we collect from three different places, or three different layers within the Windows Virtual Desktop environment. The first is the Azure APIs themselves, and we have certain knowledge of the APIs that when we know it's an Azure virtual machine, we can collect and show a lot of data. And I'll show that here in a second. The second layer is that we use the VDS API to provide context. So we know which user has been assigned to which machine, where that session went to live, because we're listening for the WVD feedback from that, but we're also combining it with the information that we have that the administrators have done on the configuration side. So it's not just a virtual machine. This is a WVD machine that's in this host pool that was assigned to this user and is being used on Tuesday from this hour to this hour kind of thing. So we have information that fills out some of that data. The third layer is that we run an agent called Telegraph. It's an open source agent that will allow us to see any of the perfmon data on that machine. So we can pull that information back in and again, build out details that you typically wouldn't see at the overall VM level because we're interested in session information. So what's the user latency? What's the network utilization, CPU utilization for that session, et cetera? We can provide that third layer of information. So by combining all three of those, we get a pretty complete data picture. And then our goal here is to use that data in a meaningful way so that we can help with administrators. So I'll just give you two examples here quickly. One is this is the virtual machine object in the Cloud Insights, and because, as I said, it knows. I'm sorry, this is the combined view. So this is the host pool itself. We get all the information, and we can actually see, based on our thresholds, that we're okay on CPU utilization here, but we're a little bit concerned that in aggregate, this host pool has been running a little bit hot for the time period that I've chosen. It's 7-day average for this stuff. So it's in the mid 70s here. We want to keep it, I'm sorry, mid 60s. We want to keep it high on that, but the CPU utilization means I've probably got the right machine size from a processor side, but the memory utilization, we have to see if that's going to be a trend that continues for those pieces. I can also look at it graphed over time, 30-day sequence, everything from 3 hours to like 90 days. Tell me what I'm doing here, so I can see whether the environment's changing or if the trend lines over time indicate that I should resize the machines within a particular host pool. So that kind of feedback allows us to track a lot of information. We can also see our utilization, see the highs and lows for sessions for each host pool. Gives us an idea of utilization on top of performance while we're running the sessions for those pieces. So this dashboard allows us the ability to see trend information, allows us to set up these sort of red, yellow, green thermometers. It also will give us the capability to do alerting if we choose to tell us, okay, if I'm running above a certain level, I can have it alert me after a certain period of time that this particular host pool is running hot. So you could set an alert for that piece of it for those elements. The other element is that because I'm on a known Azure virtual machine, we already have a lot of information that Cloud Insights knows based on its native collection from that environment. So you can see it has all the information for the machine. It can even tell you which hypervisor it's running on, which policies have been applied to it from that side. But we also get the information for machine by machine, things like IOPS, CPU utilization. You can see that I've already hit the trigger a couple of times here. The red dots tell me when I'm above a threshold for that piece of it, as well as some of the underlying technology details for this piece of it. So by combining the already sort of known components of the Cloud Insights public cloud infrastructure that's targeted at Azure, I can actually collect information that I can then break down into session-specific information when I get to the deeper dashboards. So we just turned this on last week. We're getting a lot better at collecting the information. And as you see the evolution of this, VDS will collect this information and start returning that back into both the VDS web application and coming up with recommended sets of dashboards, queries, and alerts so that you can see elements that are very focused on VDS. It also gives us access to see the performance of things like ANF. So that question, the very popular question of, okay, what do I need in terms of capacity and throughput in IOPS for this particular group of users? We can monitor that over time and see if we have to adjust the ANF sizing or tiering to be more responsive to get that data off the storage layer and back onto the storage layer without having traffic jams when it comes to running back to that layer. So Patrick, that was the high-speed tour. See if anybody has questions or follow-ups based on that.